Hello everyone, my name is Sai, and today we're going to do some circuits. Now, circuits are really cool. I mean, you could do pretty much an infinite amount of stuff with it. I mean, you could add a bulb into the circuit, you could add another battery, and if you get up to 4 batteries, you can actually blow up the light bulb, which I never did, of course. Alright, let's get into the circuits. So there's two types of circuits, series and parallel. Now, there are some key differences between these two, but we'll get to that in a second. First, let's figure out how a series circuit works. So, for any circuit, we need a battery, which is our power source. So, this symbol with these two lines represents a battery. And then, if we get out our pencil tool, this long line is the positive end of the battery, this short line is the negative end of the battery. And then all we have to do is draw a wire going around to make our circuit. And then this is where it gets interesting. We add what's called a resistor. So that's a resistor. And then we go all the way back around and back to the battery. So what current does here, it goes around here. It travels through the resistor. It goes back around the wire and goes back into the battery. Then it goes back around and it keeps going. It's a loop. Alright, so what does a resistor do? Well, a resistor pretty much slows down the current, or at least it controls it, sort of like a traffic police. So if there's a bunch of cars going down the road, a traffic police makes sure that too many cars don't rush down, because if the cars go too fast, then the circuit might blow up. So that's what the resistor does. And you might ask, why not just slow down the current? Well, we can't actually do that. And even if we could, well, once it gets to this, because in real life, this resistor would be a light bulb. So if too much current is going through the light bulb, then the bulb would blow, sort of like I did in the physics lab. So there's a really important formula for series circuits, and it's really not hard to memorize, but it's so useful. It's called Ohm's law, and it pretty much says V equals IR. And it's really simple and it's super useful. So what the V represents is how strong the battery is. So we classify how strong the battery is by saying that its voltage is equal to, let's say, 15 volts. So how powerful the battery is measured by voltage. So in this case, voltage equals 15 volts. And then we can also tell how strong the resistor is, but we don't use voltage for resistors. We use resistance, so which is represented by R. So R equals 3 ohms. All right. So let's make that bigger. Awesome. All right. So R equals 3 ohms and V equals 15 volts. So now just doing some mental math here. 15, which is the voltage, divided by R, which is 3, equals 5. So I equals 5. But what in the world is I? Well, I is the amount of current flowing through the circuit, and the unit that we use to represent I is amperes. So I equals 5 amperes, as we just calculated. Alright, there we go. So I equals 5 amperes. Now, we can do something cool with series circuits. We can actually erase this part of the wire, and then if we get our pencil tool, we can add another resistor. Let me undo that and make it a bit neater. Awesome. Alright, and then we draw the wire around and perfect. So now, just for simplicity's sake, we'll say that this resistance is also equal to 3 ohms. Alright? It doesn't have to be, but just so we get the point, we're gonna make this equal to 3 ohms. Perfect, just like this one. Alright, so now, let's use Ohm's law. But wait, now we have two resistors, so which R do we use? Well, when we have two or more resistors in a series circuit, we add up their resistances to get the total resistance for the circuit. So in this case, 3 plus 3 is 6, so the resistance is equal to 6 ohms. And then we don't know the I yet, because now we added a resistor, so it's no longer 5 amperes. And we know the voltage because it's 15. So all we have to do is go to our trusty calculator. 15 divided by 6 is 2.5. So the current of this circuit is 2.5 amperes. Awesome. Now, what if we use this resistor, but we put it in a different place? So, series is pretty simple. You just add up the resistances. And parallel circuits are pretty simple too. But it's a little bit different, so we just have to get used to it. Alright, let's get the big eraser so we could do this a bit faster. And let's keep Ohm's law, just so we don't forget. And then we'll keep that one resistor there, because we're going to use it. And then let's get out our pencil tool and put this wire back. So this is what we started with. Now we can add another resistor this way, and this is called adding a resistor in parallel. So this way of adding a resistor has special properties. For example, at the Museum of Science today, I did an activity where I created a series circuit with two resistors like we did before with one battery, and both light bulbs were on, but they were really dim. And then we put the bulbs in parallel, and they were both really bright. So the way it works is we have some current. It comes out of the battery, and it travels down the circuit, and then it gets to this junction, this intersection, and it's like, what do I do? So it decides to split up. So part of it goes that way, part of it goes this way. And it goes all the way around, traveling through the resistor, goes down, and then this one goes from here to here. And then they meet up at this intersection, and they continue, and they go down back to the battery, and continue as a loop. Alright, so a great question to ask would be, why does the current split up? I mean, why can't it just go down one resistor? It seems much more simpler. Whoops, let's redo that. Alright, so if the current goes down here, imagine it like the current is a bunch of kids at your school, and these two branches represent school hallways. So if you send all the kids down one resistor, then everybody's going to start tripping, and nobody's going to be able to go faster, and it's going to be harder for the current to get back to the battery. But if we split up the group into two parts, and one part goes down here, and one part goes through here, then they can travel much faster, and then they can go through here. So current always likes to take the shortest path and the most efficient path, so it splits up so that nobody starts tripping over each other. So that's how parallel circuits work. And there's one more formula that we need for parallel circuits. It is 1 over Rp, which is the resistance of the parallel circuit, equals 1 over R1 plus 1 over R2, oops, not a question mark, R2, and so on and so forth, based on how many resistors you have. So let's make that bigger. Awesome. Alright, so what this means is that if we're trying to find the resistance of the parallel circuit, then we have to take the inverse of the resistance of this resistor and the inverse of this resistance, and then we add them together, and then we take the inverse of that to figure out the resistance of the parallel circuit.